So welcome back to the live session, next live session for TCS NQT at Shikuya. I would request all the viewers, those who are watching this video, please subscribe to our channel as well as hit the bell icon so that you will be able to get the notifications. Also, we have some important updates. We keep on spreading, we keep on posting a lot of updates about TCS NQT, as well as I think the Capgemini off campus is also live now with the registration has been started. So we are trying to come up with a lot of updates on Capgemini as well. So join the Telegram channel of Shikuya, and the link is available in the description so that you will keep yourself updated about all this recruitment process. So today I'm going to explain the frequently asked questions from mensuration, and the first problem is there on the screen. So please read the problem carefully so that I would be able to explain you the answer. And the problem is the perimeter of an equilateral triangle and regular hexagon are equal. Means we have a equilateral triangle, right? We have an equilateral triangle with us. So the side is A. Obviously, equilateral means they are equal in the length. All the sides are equal. And a regular hexagon, the perimeter of the triangle and hexagon are equal, right? So let me just try to draw a regular hexagon. All right. Right. So 1 2, yeah, done. Now according to this given problem, the perimeter of this triangle, that is 3A, is equal to the perimeter of this hexagon, right? So I cannot assume that the length of the triangle and hexagon, the side of hexagon are equal. So let me assume this particular length as x, or let us assume this as x, let us assume this as y. So according to the given data, 3x is equal to 6y. Are you getting my point? It's quite simple. So what is the relation between x and y? The x is actually 2 times of y. This is the first relation that we have. Now quickly let us calculate the area of equilateral triangle, and as we know that it is root 3 by 4 into side square, that is x square. Now as you can check in the diagram, the area of hexagon will be, we have 6 triangles over here, right? 1 2 3 4 5 6, everywhere there is y. So area of hexagon will be root 3 by 4 into y square into 6, because we have 6 triangles, 6 smaller triangles over here. So when we are trying to calculate the ratio, this root 3 by 4 will get cancelled with each other. We know x is equal to 2y, correct? So I'm going to write this x square as 4y square divided by 6y square. So y will get, again they will get cancelled with each other, and the ratio will be 2:3. So are we calculating the ratio of triangle to hexagon? Just let me check the problem statement. Find the ratio of their areas. Okay, the perimeter of an equilateral triangle and hexagon. So it is not clear, but the first figure that is given in the problem is triangle to hexagon. So let's go ahead with the same proportion. The answer is going to be B, that is 2:3. Ratio of triangle is to hexagon is 2:3. I hope everybody is able to understand the problem. Let me repeat once again. The triangle with having x as length, hexagon with y as length. Now we will be having 6 smaller triangles of length y into this regular hexagon. So the ratio of length of triangle to length of hexagon is 1:2, or the length of triangle is double that of length of hexagon. So I calculated the area of equilateral triangle, area of hexagon, and we have the ratio over here. So this is how the problem is solved. So I would like to go ahead with the second problem on the screen. You can watch this problem again and again according to your learning pace. So the second problem on screen, and I'm going to read it for you. The problem is 7 by 8 meter rectangular ground is surrounded by a 1.5 meter width path. Depth of the path is 12 centimeter. Gravel is filled, and find the quantity of gravel required. Okay. In mensuration, it is really important to visualize the given problem. Drawing the figure for the given data is the key to solve any given problem. So basically we have a rectangular ground. We have a rectangular ground, right? So this is 7, this is 8. And now there is a path. There is a path with 1.5 meter width. That means here is the path. I am drawing by a dotted line, and everywhere it is 1.5. So this is 1.5 actually. This is also 1.5. This is 7 and this is 8, right? So what we are supposed to do, we are supposed to calculate the total quantity of gravels that are required to be laid into that particular path. All right. So what we have to do here is, let us first of all calculate the area of the total area of this path, right? And as we know, the area of a rectangle is length into breadth. So area of the original rectangle, original park, is 56 units square. What is the unit? It is in centimeter square or meter square? Yeah, it is in meters square. So we have this as meters square, right? 56 meters square. Now let's try to find out the area of this path, this particular path. So how can we do it? We have to calculate this area of outer rectangle, dotted rectangle, and we have to subtract the area of the inner rectangle, that is shaded portion. So that area obviously will be 7 plus 1.5 into 2. Try to understand my point. This is 1.5. So 1.5 plus 1.5 plus 7 will get us the length of the dotted rectangle, as well as 8 plus 1.5 into 2. That means 7 plus 3 is 11 into 8 plus 3, sorry, 7 plus 2 is 10 and 8 plus 3 is 11. So 110. So we will get the outer rectangle as 110. Now look at this. So what is the area of path? Area of path is actually equal to 110 minus 56, right? 110 minus 56, right? Okay. Can you just show me the problem so that I will be able to understand? 7 into 8. Absolutely all right. So area of rectangle will be 110 minus 56. How much is remained? 4 plus I think 54 meters square is the value remained with us, right? So this is what we have now. So let's go ahead with the next step. Meanwhile, we just check whether the calculations are correct or not, right? Check whether the calculations are correct or not. Let's go ahead. Now, the quantity of gravel required will be, mm, how much is the length of this area has become this 54 now, and the height of this is 12 centimeter, so it has to be 12 by 100, right? So 54 into 12, 540 plus 110, so around 6, 540 plus 100, 640 plus 8, 648 divided by 100. So the answer has to be 6.48. Do we have it in option? We have it as 6.05. All right. So I think there is no option available with this. But anyways, the method is perfect. The method is perfect. It may be possible that 7 and 8, the values might have changed while typing in the options or in the given problem. But anyways, the problem is correct. So first of all, we calculated the area of shaded region. Then we calculated the area of dotted rectangle. We figured out the difference between these two areas to find the area of this path, and we multiplied this area by 12, that is the height of the path. I divided this by 100 because the height is given in centimeters and it has to be in converted to meters, so I have divided it by 100, and here is the answer. So in case if the options are wrong, still it's okay, the method is correct. You can check with the problem once again. If you have any doubts, you can put it in the comment. We will respond to the queries that you have with you. Let's go ahead with the next problem now. And the third problem on the screen is given a square of length 2 meter. Its corners are cut such that to represent a regular octagon, find the length of side of octagon. All right. So please check. Okay. So what is the problem? We have basically a square with us. As per the given problem, we have a square and the square has some length, right? Given a square of 2 meter length, its corners are cut in such a way that to form a regular rectangle. Okay, fine. So we have a square. Now let me use another color just for the sake of visibility. So we are going to, no, it's not working. So just check. So we are going to cut this square to get a regular octagon. So now we will have these sides. Obviously, they have to be in such a way. So basically, let us try to assume this as x and this is actually y, right? This is y. This is again x and this is y. So this is how the figure looks like. We have to understand that this is a triangle. You look at this. This is a triangle actually, right? This is a triangle. This has x and the other two sides is y. So when you look at the figure, you will realize that this is a triangle. So y square plus y square is equal to x square. Are you getting my point? Y square plus y square is equal to x square. So now we will get a relation between x and y, that is 2y square is equal to x square. So you have to understand that this is the basic relation between x and y. So let us calculate the value of x. So x is equal to root 2 times of y. X is equal to root 2 times of y, right? So just try to understand the next part of calculation now. We have been given that the length of this square is 2 meters. That is 2y plus x is 2, right? 2y plus x is 2. So we here let us calculate for x. So this is x is equal to 2 minus 2y. So when I take 2 common, I will get 1 minus y. So 2 into bracket 1 minus y is equal to x upon root 2. This is what we are getting. Y is equal to x upon root 2, right? And we are solving for x. Okay, I went wrong over here. I would have substituted the value of y directly. That would have been more easy. So 2x upon root 2, right? So when I'm going to solve this, I will get 2 minus root 2x. X is equal to 2 minus root 2x. Okay. So what will be the final answer? The final answer will be x plus root 2x is equal to 2. So when I'm going to take this common, I will get 1 plus root 2 is equal to 2. So x will be, I'm writing over here. So x will be 2 divided by, no, I think we have to check with this calculations. This part you have to do on your level. 2 is equal to 2y plus x, right? So y is equal to, I will do it once again for you. So 2 is equal to 2 into x upon root 2 plus x, right? So 2 is equal to root 2x plus x. So I'm taking this common. This will be root 2 plus 1. The value of x will be 2 upon root 2 plus 1. 2 upon root 2 plus 1. So this is root 2x plus x is equal to 2, correct? So 2 upon root 2 plus 1. So this is your final answer, 2 upon root 2 plus 1. So this is the final answer. Let me just explain you once again. We have folded this square, or we have cut this square at the corners to get the regular octagon. So the side of the octagon is x, so everywhere it has to be x. Now the portion that we have folded is y, right? So applying the Pythagoras thing, y square plus y square is equal to x square, we get a relation of x and y in each other. Now we have this y plus x plus y, or whatever it may be, y square plus x square is equal to 2 meters. That is given to us that it is 2 meters. So we can go ahead and we can solve for finding the value of x, because that is the objective. That is what we are supposed to calculate, the value of the octagon, right? Let me just check the problem once again on this screen. So find the length of the side of octagon. So we are solving this for x. So you can check the problem once again so that you will get a better idea about it. Let's go ahead with the next problem now. Perimeter of the back wheel is equal to 9 feet. Perimeter of, okay, so basically when it comes to wheel, it's circle. That means 2 pi r is the perimeter, but I think the problem is something different. Front wheel is 7 meter. On a certain distance, the front wheel gets 10 revolutions more than the back wheel. So first of all, let us assume that both of them are traveling a distance d, that is unknown. Now the wheel that has 7 as perimeter, that is the circumference is 7, has 10 revolutions more than the back wheel, right? So let us assume that the number of revolutions that each wheel is making is f. So let us assume that the revolutions that it is making is f. So the wheel with 7 as perimeter is doing 10 revolutions more than that of wheel with 9 as perimeter. So let's try to solve this. Is equal to 9f. So the value of f is 35. So we are supposed to calculate the distance, we are supposed to calculate the distance that they are covering, right? So the distance that they are covering will be 35 into 7. This is the distance that we are supposed to calculate, right? So 7 5 3 30 into 7 is 210 plus 35, right? So 5 4 245, and 9 into 35, that is the distance covered by the another wheel, that will be 270 plus how much? 45. I think what is the objective of the question? Objective of the question is, what is the revolution more than the back wheel? What is the distance? So the distance will be 9 5 are 45. So 5 7 4 1 are 3. So 315 is the distance traveled, because it is doing 10 revolutions more, right? So the 7 will be doing 45 revolutions. So I have to take 45 over here. So 200 and sorry, uh, 45 into 7. 45 into 7. So 7 5s are 280 plus 35. So this is also 350. So we are doing 9 into 35 or 45 into 7. So the total distance is 315 meters. So this is how the problem is. This wheel is doing 10 revolutions more as compared to the wheel that is having a perimeter of 9. So this is what the problem goes. I hope you have it. I'm displaying the next problem on the screen so that you give a try to this problem. I want you to solve this problem carefully. can check the problem on the screen. It's quite simple actually. It's very simple. You just have to make sure that you are able to visualize the given data. So we basically have a rectangular park. So here is the rectangular park, right? And we have a crossroad in between this particular park. So we have a track or road here. So the length of the rectangular park is 60 meters. This is 60. The length of this park is, width of this park is 40. So this is the area covered by the crossroad, right? So this is how the park looks like. Now as we are unknown to this, let us assume the width as A, right? Perfect. Now what is our objective? Our objective is to calculate, okay, the area of the lawn is, okay, so it is clearly given that the area of lawn, because the lawn is here, this portion is lawn, and it is given that the area of lawn is this much. So area of park is actually 60 into 40, that is 2400. Now area of the lawn is given to us, and it is 2109, I guess, right? Yes, 2109 square meter. Units are same. So now when we will subtract these two into from each other, we will get the area of road, area of crossroad. So 2400 minus 109, right? So that will be 200 and something, right? That will be 200 and something. Let me calculate it this way. 200, 2100 and 2400, that is 300, and 9 less than 300, that is 291. So the area of road that is given to us is actually 291. But you have to understand one thing, that this particular route will have the length as 60 meters into width as A, right? Into width as A. So the area of, I am doing the calculations here now, the area of the road can be written as 60 into A, that is length into width or breadth, plus 40 into A, that is 40 and width as A. But we have to understand, this is a area which is calculated for 2 times. It is also considered into this area, it is also considered into this area. So this is actually A, that is A square. So we have to subtract this A square, and we are getting this as 291, right? I hope you all are getting this point. This is a very important concept, or this is a very important thing that you all have to understand while solving this problem. I have added it as 60A into 40A, and I have subtracted that common area which is considered in the both cases, right? So now I am going to solve this. So this is 100A minus A square, which is equal to 291. So we have to now solve this particular problem, right? So I'm getting an equation over here actually, a square minus 100a, right, plus 291, which is equal to 0. So when you will solve this for a, you will get the answer. But instead of going for the entire calculation, you just go and check with the options that is given to us. The options are 2.91, 3 meter, 5.82 and none. So I will just check with this. 9 plus 1, 10, 10 plus 2, 12. So I think this 291 is divisible by 3. So 3 nines are 27, 3 sevens are. Okay. So we now have two options of this A, that is 97 and 3. Well, this 97 is impossible because the length is actually 60. So this A cannot be more than that. So eventually your answer is 3 meters. That is the option B. Let me explain once again what I have done. The length and area are given. So the total area becomes 2400. Area of lawns is given. I have subtracted that. So now I have got the area of the road. Now I have added the 60 into A plus 40 into A, that is the addition of both the areas. This portion is considered for the 2 times, so I have subtracted it from the given area and now I have solved it. This is important. Don't go on solving the equations. Go with the options, right? The simple was 3, so I just checked with the 3 options. So this is done. The problem is being completed. I would like to go ahead with the next problem now, which is there on the screen. Please go and check on the screen. So the next problem on the screen, a closed cylinder tank contains 36 pi cubic feet of water and it is filled to half of its capacity. When the tank is placed upright on its circular base on the level ground, the height of water is 4 feet. When the tank is placed on its side on the level ground, what is the height in the feet? Okay, so this is very simple actually. You give a try. If you're not able to do it, then I will tell you. It's very simple actually. Imagine a cylinder. Imagine a cylinder. Quite simple. The given problem is very easy. So here we have to understand that let us first of all try to understand what is the condition. So volume is given to us when the tank is placed upright on its circular base on the level ground. The height of water in the tank is 4 feet. When the tank is placed on its side on the level ground, what is the height in feet? All right, we know that. So initially we have a cylinder that is placed upside right. So this is how it's going to look like, and there is some amount of fluid into it. So it is filled, and that particular height is given to us. That is h. That is the height of the water in the tank. Now, if I will tilt this tank, it will look like this, right? And now the amount of quantity of water will be in this. So this is the height that is expected. So if I calculate in this particular way, if I will go and calculate in the other particular way, the volume of cylinder will be pi r square h, right? Pi r square h. So the radius will, we have to calculate the radius, That is the objective that we have. And once we will get the radius, we probably will be able to find out how does it going to work. Basically, this is the radius that we are trying to calculate. This is the radius that we are going to calculate. So pi r square h is equal to 36 pi. That is what we have. As we know the height is 4. As we know the height is 4. This pi will cancel with each other. So r square into 4 is equal to 36. So r is 9. Sorry, r square is 9. So r is equal to 3. So this is what will be the answer. So when we will tilt this cylinder on one of its side, this will be 3 meters height for this particular tank. So the water comes to the level of radius, that is 3 meters. This is what the problem is all about. So we are done with the today's problems. So thank you so much for watching this particular lecture. In the next session, I'm going to cover few problems of remainder theorems as well as number systems and few other problems. So I would request all of you to keep us following on YouTube, Instagram, Facebook, join our Telegram channel and WhatsApp channel. The links are available there in the description. Let me tell you once again that we are going to have some sessions about Capgemini, as well as we already are running some sessions for TCS. So we will have few sessions of Capgemini as well. So keep us on continuously following this channel. Subscribe to our YouTube channel, and hit the bell icon as well. Thank you so much.